Principal molar heat what? Capacity of oxygen. If their ratio is what? 1.40. And density of oxygen at STP was given to be 1.42 kilogram per meter what? Cube. And one standard atmosphere equals to 1.01 times 10 raised power 5 Pascal. And molar mass of oxygen 32 times 10 power minus 3 kilogram per what? Mole. All right, so let's bring out the parameters. They say 2 molar what? Heat capacity, right? And that's the what? CP and what? CP and what? CV. I told you that your CP stand for molar heat capacity at constant pressure, while CV stand for molar heat capacity at constant volume. All right. Now, this time around, we were giving their ratio. What's their ratio? 1.40. Their ratio is written as gamma, right? That 1.40. Then we're giving density. What's density? 1.43 kilogram per meter cube. And it's one standard atmosphere is written as what? Pressure. So we're giving pressure to be 1.01 times 10 raised power 5 Pascal. Pressure is measured in what? Pascal or Newton per meter square. Millimeter mercury, centimeter mercury, and so on and so forth, even in bar, which is barometer. And molar mass of oxygen is what? 32. Molar mass was given to be 32 times 10 raised power minus 3. That kilogram per what? Mole. Now we are asked to look for CP and CV. And to look for CP and CV, I gave you Meyer's equation. That is, I gave you CP minus CV equals to R. Is it not?
Yes.
All right. Now, from Meyer's equation, we can't be looking for two things at the same what time. Moreover, we don't even have our what? Ideal gas constant, right? And we don't even have this. That means we can't look for three things at the same what time. We have to look for what? Ideal gas what? Constant. And to look for ideal gas, you can get your ideal gas, which is PV, general gas law, equals to what? nRT, right? This is ideal gas equation, right? PV equals to what? nRT. So we can get our R from here, is it not? To get R from here, what do? Divide both sides by NT, right? So it becomes R equals to what? PV over what? NT. Your T there is temperature, and temperature is constant. At STP, your temperature is what? 273 Kelvin. Are you following? Now, this time around, we have pressure, right? Do we have temperature? Yes, we do. Then this one is number of mole. Do you have number of mole? Do you have number of mole? So we have to look for number of what? Mole. Do we have volume? No, we can get our volume from what? Density. Now, first of all, let's look for number of mole. From mass mole relationship, N is equal to mass over what? Molar mass. Is it not? All right. So for monoatomic gas, our N is 1. For monoatomic gas, N is what? 1. Then another thing is this volume. You can get volume from density. That density is equal to mass over what? Volume. Now the issue there is we have density. We are looking for volume. We don't have our mass. We can get our mass from this place. Once you get your mass, you substitute your mass into this place to get your what? Volume. Are you following? And for monoatomic gas, N is stating as what? N is stating as what? 1. So this one is stating as what? 1 equals to M over what molar mass? 32 times 10 raised by minus 3. Are you following? So if you cross multiply, our M will be equal to 1 times 32 times 10 raised by minus 3. 32 times 10 raised by minus 3 kilogram. Is it not? So we can now put our formula into this very one. So density is equal to mass over what? Volume. So what's density? What's density?
1.43.
1.4 what? 3. And what's mass now? 32
times 10 raised to the power minus 3.
minus 3 all over what? V. So what do you do there? Cross multiply. So it becomes 1.43 V equals to 32 times 10 raised to power minus 3. Is it not?
Yes.
All right. To get our V, what do? Divide both sides by what? 1.43. So from there, our V will be equals to 32 times 10 raised to power minus 3 divided by 1.43. So what's V? 0.0223 what? 8. So the SI unit is on meter cube. All right. Now that you've gotten your volume, the next thing now, we can substitute our volume into this place, right? To get our ideal gas constant. So our arrow will be equals to what's P? Pressure. We have arrow equals to PV equals to what? NT. So R will be equals to what's P?
1.01
Times 10 raised to power 5. Then time what's volume? 0.02238. Then all over what's N?
1.
N is 1. Then time what's temperature?
273.
27 or 3. R will be equals to multiply the numerator.
2260.38.
2260.38 divided by 273. So what's R?
8.28 joule per
8.28 joule per mole. Joule per mole. Then per Kelvin. All right. Now that we've gotten our arrow, the next thing now is to substitute our arrow into this place, right? Don't forget we have Cp minus Cv equals to arrow. Is it not?
Yes.
So from there, we have Cp minus Cv equals to what's arrow now? 8.28. That's 8.28. Now the issue there is, what are we looking for? We are looking for Cp and Cv. Can you get your Cp and your Cv from here? No. What you do, you recall from molar what? Ratio of molar heat capacity, where I gave you Cp minus Cv equals to gamma. Are you following? So what you do from here, can you just call this equation what? 1. Now, our Cp over Cv equals to what's gamma?
1.40.
What's gamma?
1.40.
1.40. So what did if you cross multiply here? We have Cp equals to 1.40 Cv. Can call this equation what? 2. More like simultaneous what equation. What you do, you substitute equation 2 into equation 1. Are you following? So you put equation 2 into 1. Now our equation 1 is Cp minus Cv equals to 8.28. So our Cp, what's our Cp? 1.40 Cv, right? What's our Cp? 1.40 Cv. We have 1.40 Cv minus what? Cv equals to 8.28, right? What's common here? Cv is common, right? Then you factor out what? Cv. If you bring out Cv, what will be left here? 1.40. And what will be left here? 1 equals to 8.28. Cv times 1.40 is 1.40 Cv. Cv times minus 1 is what? Minus Cv. Are you following? So 1.40 minus 1 is 0.4. So 0.4 times Cv, we have 0.4 Cv equals to 8.28. Are you following? So from here, our Cv will be equals to 8.28 divided by 0.4. Are you following? So what do we have?
20.6.
What do we have?
20.7.
20.7. So joule per mole per Kelvin. All right. Now that you got your Cp now, you can now put your Cv. You can now put your Cv into any of the word equation. You can put it in equation 1. You can put it in equation 2. You still arrive at the same word answer. All right. So she just put it in equation 2 because it's more easier, right? So this time I can say put Cv into equation what? Equation 2. Equation 2 is what? Cp equals to 1.40 cv, right? So from there our Cp will be equals to 1.40. What's our Cv? What's our Cv? 20 point what? So that is 20.7. So what's Cp now? 1.40 times 20.7.
28.98.
28.98 joule per mole per Kelvin. So that is our answer. Yeah, copy that. Kelvin, that's temperature T1, 288 Kelvin. Expand adiabatically. Expand adiabatically and its temperature falls to what? 273. That is from 288 to 273. So that is from here to here. Initial and what? Final. So we're getting our T2, 273 Kelvin. Now we are told that what is the new volume? If gamma is the, we are giving gamma, right? To be 1.40. Then we are now looking for what? V2. That's number one. So number two, we are now told that if it is then compressed isothermally, I give thermodynamic process now. Isothermal, isochoric, isobaric, adiabatic, is it not? All right. We are told that if it is then compressed isothermally until the pressure returns to its original value, calculate the final volume of the gas. So you can now call down to be your what? V3. Please pay attention. The first one is adiabatic. The second one is what? Isothermal. Now, adiabatically, now we are asked to look for volume. This relationship between what? Temperature and volume, right? I gave you T have Number 3. We are told that an ideal gas at 70 degrees Celsius. So that's our temperature, right? That's our T1, 17 degrees Celsius. What do? You convert to what? To Kelvin. How do you convert? That is 17 plus what? Plus 273. So what do we have? 290 Kelvin. And we are told that as a pressure of, we're given our P1, right? To be 1.0 times 10 raised to the power 5 Pascal. Now, and it's compressed isothermally, and number 2, adiabatically. Are you following? Then we are told that until its volume is half. Until the volume is what? Do you know the volume? No. It's just like you have a gas cylinder you are using at home. Are you following? And you want to go and fill the gas cylinder. Before they will fill it, they will first of all remove some air, right? Removing the air, that part of the gas will still what? Leave, is it not? Now, take note. The little gas that is inside, do you know the amount of the gas? You only know the amount of the one you have to fill, is it not? So that's it. So that very one now, which is our word V1, we can simply call it word S because it's unknown. Are you getting me? So they say the pressure now, sorry, the volume now, okay, was half of the what of the original word volume. It's until the volume is what? Half. Okay. Now to get our V2, that is half of what? Of V1. Are you following? To get our V2 is what? Half of what? V1. It's setting as 1/2 times what? X. So S times 1 is what? We have S over what? Over 2. Is that clear? I come again. They said until its volume is what? Is half. Half of what? Half of the what? Initial what? Volume. And that initial volume, do you know it? Do you know the initial volume? So what do? You can call it what? X. Are you following? Okay. So half of X, which is this, which is S over what? Over 2. Now, they say calculate in each case, which of the case? Isothermally and what? Adiabatically. So calculate in each case the what? The final pressure and what? Temperature. That's T1, T2 and what? And P2, is it not? So the final what? Pressure and what? Temperature of the what? Of the gas. Assuming gamma is what? 1.40. So we're giving our gamma to be 1.40. All right. Now, first of all is isothermal. Isothermally. So to get our pressure is PV equals to K. Don't forget, I told you isothermal has nothing to do with gamma, is it not? That is P1 V1 equals to P2 V2. So what's our P1? 1.0 times 10 raised to the power 5. Then time what's V1? X equals to what's P2? Unknown. That's what we are looking for, right? Time what's V2? S over 2. All right. So this time the setting at 1.0 times 10 raised to the power 5 S. Is it not? Then equals to P2 times S is what? Is SP2. Is it not? So all over what? All over 2. So this can cancel out this, isn't it? So from there we have 1.0 times 10 raised to the power 5 equals to P2 over 2. To get our P2, what do you do? What do you do? Cross multiply. So if you cross multiply, it becomes P2 equals to 2 times 1.0 times 10 raised to the power 5. Are you following? So 2 times 1.0 times 10 raised to the power 5.
200,000.
That is 200,000, right? Which is stating as 2 times 10 raised to the power 5 Pascal. All right. Now that we've gotten our P2, we also have to look for what? We also have to look for what? T2. Because you are asked to look for the final pressure and temperature in each case, both in isothermal and what? Adiabatic. Don't forget, isothermally, okay, I told you that temperature is constant, is it not?
Yeah.
Isothermally, temperature is what?
Constant.
Isochoric volume is constant, is it not?
Yes.
So this time around, don't forget our T2 is sitting as what? T1, is it not? Isothermal, T2 is the same thing as what? T1. So from here, our T2 is equal to what's T1? What's T1? 2 what? 290. Like 290 Kelvin. All right. So number 2, adiabatically. All right. Adiabatically. Any question? Yes, we are done. There is no formula for it. The temperature is constant. When it means something is constant, that means it does not change. Are you getting me? So what you have in your T1 is still the same thing you are going to have in your T2. So when there is still T3, you still have the same thing. The temperature is constant, it's the same. Are you following? All right. Now the next one, adiabatically, we have PV gamma equals to K, right? That is P1 V1 gamma equals to what? P2 V2 gamma. You can see adiabatic is the one that deal with what? Gamma, not isothermal. Is that clear? All right. So what are P1? 1.0 times 10 raised to power. All right. Then what's V1? S. S raised to power was 1.40, right? Then equals to what's P2? Unknown. What's P2? Unknown. You are looking for P2 na adiabatic process. We've already calculated isothermal. So this time around is what? Adiabatic. You look for P2, you also look for what? T2. Are you following? All right. So what's our V2? S over 2. So we have times x over 2 raised to power. Gamma is what? 1.40. So this is 1.0 times 10 raised to power 5. Then x 1.40. Is it not? Then equals to P2. Don't forget, everything inside the bracket is raising to what? 1.40. So x raised to power 1.40 is what? X 1.40. 2 raised to power 1.40 to 1.40. Is it not? So we have 1.0 times 10 raised to power 5 s 1.40 equals to P2, then x 1.40 all over 2 raised to power 1.40. 2.639. So this can cancel out this, is it not? What's left there? 1.0 times 10 raised to power 5 equals to P2 over 2.639. What do you do? Cross multiply. So our P2 will be equal to 1.0 times 10 raised to power 5 times 2.639. What do we have? What's our P2? 2 26390 263,900, right? Then Pascal is setting as 2.639 times 10 raised to power 5 Pascal. All right. Now that you've got it, that the next thing is to look for what? The temperature, is it not? So looking for temperature is TV, then gamma minus 1 equals to K. If its pressure is just gamma, if its temperature is what? Gamma minus 1. Are you following? So we have T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. All right. So what's our T1? What's T1? T1 is what? 290. Then times what's V1? X. Then raised by 1.40 minus 1. Then equals what's T2? Unknown. That's what I'm looking for. Right? Then what's our V2? What's our V2? X over 2. Then raised to power what? 1.40 minus 1. So we have 290 then times x. 1.40 minus 1, 0.4. Then equals to T2 then times x over 2 raised to power 0.4. Is it not? So we have 290 times x raised to power 0.4. 290 x 0.4 equals to T2 times everything here raises to 0.4, right? X raised to power 0.4, x 0.4 all over 2 raised to power 0.4 to 0.4. This can cancel out this now, right? We are left with what? 290 equals to T2 over 2 raised to power 0.4.
1.319.
1.319. What do you do? Cross multiply. All right, T2 will be equal to 290 times 1.319. So T2 will be equal to 290 times 1.319.
382.51.
382.51 Kelvin. So that's our answer. Any question? All right.